Welcome to New Word Math. I'm Jeff Jacobson, and today we're going to talk all about proportions. Let's get started. All right, before we get to our first example, let's talk about what exactly a proportion is. So first, a proportion is just an equation, right? We're going to have an equal sign, an equation stating that two ratios are equivalent. Here's an example. 2 over 3, that's a ratio, 2 to 3. 4 over 6, that's another ratio, 4 to 6, and they are equal to each other. They're in an equation. So this is an example of a proportion. The way you read this is basically saying the two ratios. 2 is to 3, that's the first ratio, as. That's where you have the equal sign. As 4 is to 6. That's how you would say that proportion out loud, and this is how it would be written. All right, let's get to our first example. All right, example 1. Tell whether 6 over 4 and 8/12 form a proportion. So we want to see if they are equal to each other, if we can make an equation with those two ratios. I'm going to show you 3 different methods on how to tell if they form a proportion. So the first method is simplest form. We compare each ratio's simplest form, and if they are the same, then they would form a proportion. So 6/4 in simplest form would be 3/2. Okay. Compare that with 8/12 would be 2/3. These are not equivalent. They're not the same. So this, no, does not form a proportion. Those two fractions do not form a proportion. All right, method 2, I'm just going to call mental math. And the way this works is if I'm comparing 6 over 4, if I'm trying to see is that going to be equal to or equivalent to 8 over 12, right? I got a question there because I'm not sure if they form a proportion. I can just use some mental math. Well, to get from 4 to 12, I would multiply by 3. Anything I do to the denominator, I should do to the numerator if it was going to be equivalent. So if I did 6 times 3, does that give me 8? No, 6 times 3 is 18, not 8. So again, that would be no. They do not form a proportion. Okay, method 3, we're going to call cross products. So again, if I write it 6 over 4, I'm trying to see if they are equal to each other. Cross products means you take the numerator and the denominator going across and you multiply them together. If they are proportional, when you multiply them together, you're going to get the same thing on both sides. So if I do 4 times 8, is that equal to 6 times 12? 32, which is not equal to 72. So once again, no, they do not form a proportion. They're not proportional. If those were equal to each other, then yes, they would be. Let's try another example. Okay, example 2. Tell whether x and y are proportional. Just like the previous example, I had 3 methods that I could use to decide whether x and y are proportional, but I don't want to do all 3. For me, I'm just going to do simplest form. I'm going to compare x and y if they're proportional, so I need ratios. My first one would be 1/2 to 3, and if I want to compare that, I could compare it with either. I'll just compare it with 1 to 6. You got to make sure that my numerators here, those are both representing the x's. My denominators are both representing the y's. If I had this switched, it wouldn't work. So you got to make sure numerator and numerator are talking about the same thing, and same thing with denominators. So let's compare in simplest form. The nice thing, that's already done. That's in simplest form. But here I've got a complex fraction. 1/2 divided by 3 is the same thing as 1/2 times 1/3, which is 1/6. And what do you know? 1/6 is equal to 1/6. So yes, they do form a proportion. They are proportional. And it wouldn't matter if I tried another one. 3 over 2 divided by 9. 3 over 2 to 9. there's my ratio. If I put that in simplest form, that's the same thing as 3/2 times 1/9. Simplify 1/3, and I get 1/6 again. And to be honest, sometimes it is a good idea to check more than one ratio, but we got 1/6 again, so yes, they are proportional. Here's some to try on your own. All right, here's our last example. You swim your first 4 laps in 2.4 minutes. You complete 16 laps in 12 minutes. Is the number of laps proportional to your time? If we're going to find if they're proportional, we first need our ratios. Well, our ratios are going to be time to laps. So if I look, it took me 2.4 minutes to do 4 laps. If I want to compare that with this, it took 12 minutes to do 16 laps. If I want to compare them, we've got those 3 methods. I could do simplest form, I could do mental math, or I could also do that cross product. Right here, maybe you see that mental math would be really, really useful. To get from 4 to 16, I would just times 4 times 4. 2.4 times 4 is going to be 9.6, which does not equal 12. So that would tell us, no, they're not proportional. But that's just one method. Let's try another one. All right, if we want to try another method, we could try simplest form. Well, right here we've got a decimal in the fraction. So let's first get rid of that. So we would make this times 10 times 10. So that would become 24 over 40. And then if we simplify, our common factor looks like 8. Divide by 8, divide by 8, and we would get 3/5. If we simplify this, common factor is going to be 4. We would get 3/4. Notice, again, they don't have the simplest form, so they are not proportional. If we wanted to try another method, we could also compare their unit rates. As long as you've got both the denominators the same, then you just look at the numerators. So that would be 2.4, right? Divide by 4, divide by 4, so that we get 1 in the denominator. 2.4 divided by 4 would be 0.6. So that means it's taking 0.6 minutes for 1 lap. There's my unit rate. How about here? Divide by 16, divided by 16. Well, 12 divided by 16 would be 16 into 120 would go 7 times. That's 42, 4, that's 11. You get 8 left over. Bring down a 0. 16 into 80 would go 5 times. 0.75 minutes to go 1 lap. Again, comparing their unit rates, they are not the same, which means they are not proportional. And if you're wondering why is the amount of time not proportional to your laps, you're going to get tired. Here's one more to try on your own. As always, thank you so much for watching, and if you like this video, please subscribe.